Hello and good morning, good afternoon. I'm Andreas from Semantic Web Company, and I'd like to welcome you to this webinar. Thanks for coming. We start on time. Some of you have already participated in a voting, so the voting is now closed. Most of you have participated, and the result is quite interesting. So the question was, are symbolic AI approaches still relevant after all the successes of deep learning? And 36% of you said yes, 7% of you said no, and 57% are not sure. Well, I guess that's a good opportunity for me and to give you a bit of an idea during that webinar whether symbolic AI, artificial intelligence, is still relevant or not. Today we will also present to you the latest version release of PoolParty Semantic Suite, which is the version 6.2, which now is shipping a new technical component, which is called the PoolParty Semantic Classifier. And this is really in the center of our interest today. And we will talk about machine learning. We will talk about NLP and knowledge graphs and how those things come together. And the semantic classifier is one of those applications which are now on the market available, in which those interesting and exciting new technology trends come together. So I'm really happy to have you with us. We will start with a very quick introduction of the company behind PoolParty and the PoolParty itself. And then I will go straight into the agenda and hopefully some interesting topics for you today. So, as I've said, my name is Andreas Blumauer. I'm CEO of Semantic Web Company. We got founded back in 2004. We are based in Vienna, privately held, a bit more than 40 full-time equivalent, and all of them are really experts in NLP or semantics or machine learning. So I'm really proud to have a really great team here at Semantic Web Company, who is also capable to bring together such rather complex technology trends and make that available as a real good product. In recent years, we've seen a nice growth rate. We also have a bit of funding for research and development, which is important in this very dynamic environment. And we're also proud to be named as one of the 100 companies that matter in knowledge management by KM World in the past 2 years. The PoolParty Semantic Suite was first released in 2009, and today we celebrate the newest release, which is 6.2. And what's important to know, most of all, it's a software which is W3C standards compliant. So it's based on the semantic web standards. We have roughly spoke a bit more than 200 installations worldwide, and a lot of the revenue is always reinvested into further product development. So this is also important to see. It's a very dynamic product which evolves quickly along the current trends, for instance, derived from artificial intelligence. PoolParty can be installed on premises. That's important. If you want to deploy artificial intelligence in your company, I think it's also good to know that you can control that. You don't have to give away the data to an AI API. You can really run your own AI stack when using PoolParty. And also this software was listed by KM World in recent years as one of the trend-setting products, and we're also very proud of that. So this was really just a very first quick intro, and today I want to introduce you to a new field which we call Semantic AI. What is it? How is it related to other AI technologies? I also want to revisit a little bit the current status of artificial intelligence in general, and then give you examples of what semantic AI can be, what it can provide to you, which use cases are possible on top of this. And as an example, I want to introduce you to PoolParty 6.2 and its brand new Semantic Classifier. Show you a live demo, explain to you how it works, give you a couple of benchmarks to see how you benefit from it, what's the difference to other classification tools on the market, and then give you integration scenarios. As a final round, I want to give you a couple of use cases, how semantic AI can be used in general and how the semantic classifier in particular. I also would like to ask you to stay with me after the webinar has closed in about 45 minutes or so, and stay with me and the others in this discussion. And I will open up the microphones, and hopefully we have some interesting topics to discuss, or maybe you have some questions or other things you would like to share with us. Also, for just housekeeping stuff, you can download two handouts, if you like, that should be available in your dashboard. And please ask questions whenever you like. I will look up the question dashboard from time to time. So just give me your questions whenever you want, and at least at the end, we will discuss your questions anyway. Okay. So, what is semantic artificial intelligence? Let's take a look on AI in general. So, in a nutshell, you could say it divides into three big fields. The one we from the semantic web community mainly come from would be called the symbolic AI. So you will see that on the right-hand side. Some also call it good old-fashioned AI. I like that term. On the other hand side, you have statistical AI and then subsymbolic AI. So this was discussed heavily since, I would say, the 60s or even earlier. And we can now see a lot of great developments in all those fields. If you look down at statistical AI, of course, machine learning is one of those, let's say, families of methodologies we frequently see. And here, one of those, which is deep learning, was really successful to fulfill several tasks in recent years. And as we will also see, it's now more and more combined with many other methodologies and algorithms. And today we want to take a look on what happens if you combine it with knowledge representation, knowledge graphs and reasoning, knowledge extraction, which is also one of the methodologies based on knowledge graphs, and combine those together as a result, for instance, having something like a semantic enhanced text classification or entity recognition and entity linking based on those two methodologies. So how can that be done? How could that work? And we can also briefly look into options, for instance, to improve methodologies like word embeddings based on knowledge graphs. And as a result, of course, we will look into natural language processing in general, how that benefits from a fusion of those different methodologies. I will become more concrete. So this is really just a quick overview, especially for people in this room who have probably not that much seen the difference between the different artificial intelligence approaches taken in the last 50 years or so. One thing I really want to make clear, currently the term machine learning has really kind of hijacked the name artificial intelligence. Many people believe that's AI. Machine learning is AI. Since I'm from the semantic web community, I really have to say, no, that's not true. Knowledge representation and other artificial intelligence technologies, of course, are still there. And you will see hopefully how those things can come together also to make use cases happen which are interesting for you. So this is the first round. And the second thing I really want to discuss now, AI is a little bit hyped currently. And I'd like to bring that a little bit down back to earth and try to make a bit of an assessment of the current status of artificial intelligence. So what makes someone an intelligent being? I think we should be clear. With machines, we are, of course, always excited when they can do something what a human being can do, of course, and naturally in a sense. And let's take a look on one map of cognitive processes and classify tasks on top of that. So what is quite useful for that is the so-called Bloom's taxonomy, which classifies different tasks, like from remember, over understand, to apply knowledge, analyze, evaluate, and create something new. So Bloom's taxonomy kind of also talks about, of course, of increasing complexity from 1 to 6. And if we look at a couple of questions, for instance, which are typical for those processes, you see it's like who is, where is, or also why did would be already a remember task, and it's getting more and more complex. So to understand, or in order to prove that you have understood something, you should also be able to tell the difference between, for instance, two things, or what the main idea of something is, and so on. Or going further up, apply knowledge. So why is something significant, or how is something an example of something else? Or analyze is a very complex task already. So how is A related to B, and so on and so forth. So you will see quickly, of course, anything what we currently call AI is a very, very specialized, is modeled or is developed to fulfill a very specialized task. So any of those tasks are probably still far too complex to be fulfilled by machines. But, and this is very interesting, I would say, each of those, even creation of, let's say, music, and I will show you an example afterwards, can already be done by AI. We just have to be clear, it's not really creativity, but it supports creativity of human beings. So we will hopefully be able to discuss that a little bit further after this introductory presentation of mine. Of course, some argue it is already creativity when deep learning algorithms, combine already existing stuff and make something new on top. Let's discuss that later. But I want to show you a couple of examples where you clearly can see if you go beyond remember and probably understand, then it's getting really tough for machines to fulfill tasks. Let's take a look on the first level, remember. So here I see knowledge graphs, and therefore symbolic AI and knowledge extraction, one of the methods you can build on top of knowledge graphs, are really great to be used to do a good job with, answering questions like the ones I've just shown you before. Let's take a look at a very, very simple knowledge graph. So for instance, we've got a city, a country, and an international organization in our knowledge graph. And we have most probably, or most likely, a standards-based knowledge graph in place. We can enrich that maybe with facts from other knowledge bases with low cost, and we can do entity extraction and probably also fact extraction from unstructured information, of which we have tons of it out there on the web in our repositories. So that's great, because in order to simulate kind of an intelligence which is able to answer questions which are already quite complex, you need, for instance, to avoid illogical answers. So this kind of dialogue I just recently have seen with one of the leading assistants out there. So asking how far am I away from Perth, Australia, should not end up with an answer like the distance between Perth and Australia is 1,100 miles. Because any intelligent person knows, of course, that a city which is located in a country does not have any distance. So this is stated here in this ontology, if you want so. And if you include a knowledge graph like that in your question answering machine, you can instantly avoid such answers. So this is one of the reasons I believe a knowledge graph does a really good job in addition to machine learning algorithms. Another reason I believe it's hopefully clear that a knowledge graph can help you with such question answering machines is this example here. So which cities located in the Commonwealth of Nations have a population of more than 2 million people? Could be a question you're interested in. You might have information from different text documents, but in that case, one thing would be missing. Australia is part of the Commonwealth of Nations. So the great thing about standards-based knowledge graphs in combination with knowledge extraction is that you can use all that information as it were one single database, as it were one single graph. So anything is there. It's probably not on the text level, but in combination with the graph, you can give already answers to that question. At least you can include Perth as one of the cities with more than 2 million people located in the Commonwealth of Nations, because you can infer from this hierarchy that Perth is also located in the Commonwealth of Nations. So this is one of the reasons the semantic web community believes that knowledge graphs are a great deal. So did Google. Google, introduced knowledge graph, its own knowledge graph, around about, I think it was 8 years ago in the meantime. And of course, it's not the only component in this huge information processing machine, but it builds kind of a backbone for lots of different services. But we will also see that, of course, a lot of machine learning comes into play. In any case, it's a mixture of automatic extraction from text, fact extraction from text, and a lot of manual curation work, how this knowledge graph was built and is still maintained. So this is also something people should be really clear about. Even large companies like Google, with a lot of information and a lot of technology power under the hood, is not able to create a knowledge graph completely automatically. And I also want to point out, of course, Google Knowledge Graph is a great deal, but it's just accessible via API. That means if you build your own applications on top of Google Knowledge Graph API, you will become more and more dependent from this company. And there are lots of alternatives out there. So this is a snapshot of the semantic web. And it covers billions of entities, billions of facts. And you can pick from those, and you can build your own AI technology and strategy on top of that data. And you can control it, and you don't have to reinvent the wheel. And this is, I think, one of the most interesting facts, probably for some of you who haven't got in touch with semantic web technologies that much yet. It's something which really fits together. So all those bubbles represent its own data set. So for instance, here we have DBpedia, which also is kind of the nucleus of the Google Knowledge Graph. And it's connected with a lot of other bubbles. That means it's highly modular, and you can add your own bubble internally into your own system if you like. So it's like Lego. You can really plug and play, so to speak, and put data sets in place when needed, for instance, for machine learning activities. So try out maybe the interactive version, and you get quickly an idea how big that is already. So it's out there on the web. It looks like that. So you can pick several data sets and see how they are connected to each other and go to them, download them, and so on. So this is something, I guess, which is a really interesting offer. Now we come to the second level, understand. So that's the second level of Bloom's taxonomy. And kind of a simulation of understanding questions is done with Google's, for instance, a sentence compression algorithm, which is based on deep learning. So how does it work? You might have seen such boxes frequently in recent times when you ask a question in Google search bar. And what you get actually is a snippet of text, which is supposed to give an answer to the question you had. And that can be extracted from text and large text repositories by learning, in that case, from news articles. So that there is kind of a archive of news stories, which builds the basis for this machine learning algorithm. And by that, the algorithms figure out, okay, which parts of a news story is the most important one compared to the title of the news article. And a very similar pattern you can follow if you have a question and an answer in an article. But still, it needs a huge team of linguists to train this system. So again, you see it cannot be done completely automatically. And to be honest, this is not understanding really. So the machine does not understand what the difference between A and B really is. It just finds answers from text based on some, I would say, it's not because the machine has understood really what the difference is between those things that it found the answer. It's really just because it's similar to other cases in which obviously already human beings have marked up the most significant phrases and portions of a text. So by that, it's already symbolic AI and machine learning in combination. But it's a very interesting approach, I would say. And now I skip. So this is, by the way, an online music on YouTube you will find from AIVA Technologies. So it was generated by a deep learning algorithm. And so deep learning was done on top of compositions of Mozart and others. And the machine generated new music, which still was played by an orchestra. So it wasn't really generate the music itself, but rather the score. And what you see here, and that's very interesting, AIVA's creators also say or see the future where man and machine will collaborate to fulfill their creative potential rather than replace one another. So I think this is the long story short. Here at Semantic Web Company and PoolParty, we are believers of a combination of that. And we also see a lot of opportunities still for human beings to play a very, very essential role in such systems in the near future. So try it out. It's a very interesting kind of music, I would say. So coming to an end with this first segment of this presentation, I would like to try to give an answer of what is semantic AI. So, of course, in a nutshell, in semantic AI, various methods from symbolic AI are combined with machine learning methods and or neuronal networks. So what does Peter Novick say, the research director at Google? By the way, that's exactly the question I put in the poll just before. So Peter's opinion is a clear yes. So they are still relevant, and then you can read, by the way, the download. The presentation can be downloaded in the dashboard, and it's also on slideshare.net if interesting for you. So it's just yet another confirmation that there's lots of opportunities also from a perspective of people like Peter Novick from Google that such things can be nicely combined. So the question rather is, what are the concrete examples of such combinations? So first, semantic enrichment of text corpora to enhance word embeddings. That's one of the clear options we've got here. So for instance, that would be represented by this connection here, or extraction of semantic features from text to improve machine learning based classification tasks. So that's, for instance, something you would see here as a combination. And that's the PoolParty Semantic Classifier also working on that principles. I will show you and hopefully be able to prove to you that this improves something which has been already done by machine learning only, but it improves it. Next one, combine machine learning based with graph-based entity extraction. We see here great opportunities to enhance each of those and put it together into one thing. So this is underway in PoolParty Semantic Suite, by the way. We currently work on that. And then I think as the holy grail, really, the masterclass of Semantic AI is knowledge graphs as a data model for machine learning. And this is really exciting. I guess that's going to be one of the big things in the next 5 years, or over the next 5 years. It has already started. We have seen first results and good insights, for instance, from people from Vrije Universiteit in Amsterdam. So they do great work on that, or also people at University of Leipzig, at AKSW, they do a lot of work in that field. But still, it's a bit research-oriented, but it's coming quickly. So how could it work? I mean, one of the big things about semantics really is you can use it as an integration technology. And, you know, most machine learning activities, actually, you can read it also here. Most machine learning activities really try to break down the data into one format in feature vectors, and there's a bit of a loss of information by that. And you don't see actually the data integrated as an input into your machine learning activities. But in reality, if you want to, for instance, build a recommender system for some, let's say, product marketing activities, you never make use of all the data available around users and products. It's always just a segment of it. It's not really that machine learning is based on a unified view of the business objects. And the semantic layer in place actually is repairing that problem. It's first of all serving as an integration or integrated data model to bring all the information you have at hand for certain business objects. You bring that together in the semantic layer, and when having machine learning algorithms which can deal with such knowledge graphs, you can do that directly on this unified and standard space data model. So this is clearly set the advantage and the opportunities we can see here. And what is quite nice here, it's explained top of 3 examples how to benefit from using knowledge graphs as the data model for machine learning would be, first of all, it allows for true end-to-end learning. Second, it simplifies the integration of heterogeneous data sources and data harmonization. And third, it provides a natural way to seamlessly integrate different forms of background knowledge. So if you're interested in that, read about it. It's a great paper, but it's still a paper. And this is exactly what I want to say. With Semantic AI, we are now in the first phase, and the PoolParty Semantic Classifier is already a technical component ready for you to be used in your organization, in your enterprise. And it already is a combination of both machine learning and knowledge graphs. And now I want to present it to you and explain to you how it works. So, first of all, it does what any other classifier also does. It classifies mainly text in that case. So it's at the end, it's the same end product, which can be accessed through an API. You can send some documents or text to the PoolParty Semantic Classifier, and in return, it's going to be classified automatically. It uses, or you can pick from one of those machine learning algorithms if you like. So, for instance, you can either use support vector machines, or maybe deep learning, or naive Bayes, or any of the others shown here. So this is something which is in place. It's a user interface. You can select from those machine learning algorithms, which makes it really easy to be used. So it's user-friendly, and also people who are probably not in Python and other script languages can now really use machine learning algorithms like those quite nicely. And as you will see, it also makes use of semantic knowledge graphs. And this is exactly the key differentiator when it comes to precision recall. So some other feature highlights. As you can see, you quickly get an overview of how, for instance, several trained classifiers working better or worse than the others. So you get a quick overview of which of the classifiers you should use. This kind of user experience, of course, is quite helpful for rather the domain experts, the people who know about the business, which feeds that machine learning algorithms, and it encapsulates, so to speak, a bit better the activities currently seen or executed by classical data scientists. So it helps a little bit more, as PoolParty always tried to achieve, let's say a clearer distinction between roles in the overall system. So you've got taxonomists and knowledge engineers on the one hand side, you have the data scientists on the other hand side, and the subject matter experts, of course, always play a very important role to train such classifiers. And you can imagine such interfaces really help you to produce a classifier without, deep knowledge in typical data science tasks. It's still very scalable, so you can run and operate the classifier on top of a Spark cluster if you want. It can be easily integrated, like most of the other PoolParty services, like the extractor or the knowledge graph API, anything like that can be accessed via REST API, and so does the Semantic Classifier provide you with a REST API. I will give you also an example how that can be integrated in other PoolParty components, like the graph search component, as a concrete example. And another aspect might be interesting for some of you who have already worked with AI. Sometimes it feels like a bit of like a black box approach. So you don't know really why the machine predicts this or that. And in certain industries, that's really critical. So, for instance, in banking industry, if someone doesn't get a loan because of, well, intransparent reasons, just because the machine said, well, sorry, this client should not get a loan, then you run into problems. And I believe there are many other industries where something like a more explainable AI makes a lot of sense. With this approach in place, there's still a huge portion of what can be controlled by the subject matter expert. Of course, like any other machine learning algorithm, and if you use deep learning, you never know exactly why the machine came to that conclusion. I mean, this is the whole idea of deep learning, really, that the feature selection is done kind of automatically. But still, you can control or see which features at the end were picked, and I will show you how that looks like. Excuse me. So I think it's also about time to see or talk a little bit about a difference between three things which are frequently a little bit compared to each other, so to speak. So there's on the one hand side a classification of documents, in that case, of whole documents, of whole text fragments. On the other hand side, you have the extraction of things, of concepts, of entities, of terms. And then with PoolParty, also a third service comes into play. It's called the categorization service. So just to be clear, if you want to, for instance, find out which category a certain document is, let's say news articles, is it politics or is it health or is it economy, then usually we talk about classification. So a classifier can put it in a category, or it can label the document, as it's also frequently said. Same result is produced by a categorization service, but the categorization is based on a taxonomy. So in many industries, you have already pre-built taxonomies at hand. So it's not really a limitation. Classification of documents sometimes works also even much better when a taxonomy only is used. With the classifier in place, we will see you can combine things. So you can use machine learning only. You can use machine learning plus taxonomies, and you will see in many cases that enhances the results. With a categorization, you need a taxonomy in place. So it's not really involving machine learning in a statistical sense. Extraction is, as already stated, the extraction of single things, of single entities, but also of terms found in documents and in text. So this is a precondition to do a better classification, as we will see, but it can also be used for totally other purposes. So extraction of entities can help to do knowledge discovery, and other things. It usually enriches a search index to have a better search result and stuff like that. So this is what extractor does. So how does it work in general? How does PoolParty Semantic Classifier work? First of all, you have to determine classes or labels. So into which classes do you want to put your information into? Then you have to identify training documents per class. So you see it's a supervised learning method. Then you create the actual classifiers in the user interface. You will pick a machine learning method, you choose the correct parameters, determine used features, and then you train the model. After that has happened, you will get a result, how well the model was trained. So what precision recall you have to expect when you now send a new document into the classifier. And that's called the so-called F1 score. So the F1 score gives you an indication of how well the classifier was trained. And the training can be done either via cross-validation, so no need to have yet another document set, or you can also find out the quality, or you can determine the quality of your classifier with an extra training document set. I will show you in a second. Usually you iterate on that several times, and after a while you have reached a good level of F1, and then you are ready to deploy the service and make it available to your content workflows through the PoolParty Classifier API. So this is a screenshot of how, for instance, you can figure out why some text was classified in a certain way. And here you see, for instance, the picked concepts and terms from the text, which at the end made the difference, which determined, okay, this document belongs to this or that class. So you make it transparent by that. And now I think a really exciting fact comes into play. Classifying documents and all the different algorithms out there are really very, very competitive. So it's sometimes really hard to improve on already existing algorithms. So at PoolParty, we did not try to reinvent the algorithms themselves. So we were really just focused on the quality of the input data. And with semantic enrichment in place, this is an obvious, let's say, opportunity for us as a semantic web company to do something in that field. Usually, our customers are in the situation to have a well-shaped thesaurus or taxonomy in place to describe their knowledge domain. So in that case, for instance, for renewable energy, you could use the Regal thesaurus. It's out there, it's for free, you can use it, but there are many other examples for that, or for other domains, for other industries. And with the PoolParty Semantic Classifier, we just, used or reused the already existing entity extractor plus the, as we call them, so-called shadow concept extractor, which learns from large text corpora on top of the vocabularies. And by that, we can train the classifier with better input data. So it's not the text only, it's the semantically enriched text, which then will be used by the machine learning algorithms. And we ran hundreds of tests, of course, to figure out, okay, is that better than the usual ones? And I would say, of course, you cannot just say scientifically correct, it's better or it's worse. That's not the case. Of course, it depends. It depends on the quality of the thesaurus. It depends on the lineage between the thesaurus and the actual domain and the documents, which usually have to be classified. So if there's a strong correlation between those things, and that can be determined mathematically, then we see a high probability to enhance on the, let's say, the classical methods, which are represented by line number 1. So the same training set would have reached with linear support vector machines 83 F1 only. I mean, that's good, but it's still much less than 87 when you use the thesaurus plus the linguistic model calculated on top of the corpus, and by extracting the so-called shadow concept. So as you can see, it's an improvement of 5.2%, and that's a lot. That's a lot, as we will see in a business case afterwards. Also, as a last input in terms of theory, so to speak, just to make sure to put it in the right place. The classifier is a component of the PoolParty semantic suite, which consists of several other components. One thing you see here is the transformation from text into RDF, feeding back into the knowledge graph, which then again enhances the entity and feature extraction. So it's kind of a learning system. And you also have this classifier together with the entity extractor at hand to determine the semantics of any given text or data pushed into the system. And then on this side, you also see the unified views component, where you can orchestrate and schedule such activities, where you can feed your RDF graph databases. And another component on top of the graph databases is the PoolParty graph search. I will also talk about that in a minute. So this is just a landscape where the classifier sits is basically here. So that's just an example. So this document was classified as a fact sheet, for instance. And by that, you can inform the unified views system and do something with your document. So you can integrate the API with the API and build your own unified views data processing unit, or you can build your own recommender plugin in graph search or document classifier in graph search, or just use it in a different system. Any content management system can benefit from the PoolParty Semantic Classifier, at least in theory. Now I come to the last part of my presentation. We now come to the use cases and also a live demo of the system. So a couple of examples, just to give you some ideas how you could use the semantic classifier. So for instance, you could reduce manual effort of classifying inbound documents, news, whatever. You can build a recommender. So you can identify, for instance, appropriate agents in a help desk system, or you can use it for matchmaking. You could, for instance, also improve customer retention management and do sentiment analysis based on a semantic classifier. Or you just enhance your domain-specific text mining, or rather tricky text mining tasks like an analysis of judicial decisions, or you could complement a rule-based system for fraud detection by using the classifier. So all of that, or those activities are just examples. I guess many others make sense, but I will talk briefly about concrete ones now. So one thing I'd like to bring in is, for instance, a customer of ours is the EXO Group. They are very successful with operating the Knot, which is in the United States a really large provider of services around wedding. And at EXO Group, it's quite clear for many, many years that machine learning and semantics should play together. And you see here a couple of reasons, which are quite clear after all. So content aboutness in a defined framework would be one thing, which obviously leverages the quality of input data for machine learning algorithms. Or, for instance, the granularity you gain from a semantic model helps to get more specific recommendations. So the Knot really lives on automatic recommender systems, which help the people and the users to find the right services and compose the perfect wedding. A business case on top of this 5.2 improvement I was talking about before could look like that. Let's assume you run your own help desk and there's maybe 100,000 documents coming in per month. A quite realistic amount of money could be €5 extra per document when misrouted. And with a 5.2 improvement percent, you see the calculation down there, you would save around about €300,000 per year. So that's quite a lot. And I want to also give you a quite concrete example, which is a issue classifier. So it could look like that. So this is, I hope I'm still logged in here. So the support issues, let's go to developer issues. Okay, let's go back here. So we have a dashboard, okay? And let's assume you are working in a help desk and issues coming in, tickets coming in, and the tickets then will be classified based on a semantic knowledge graph describing your products, your technologies, and they're classified based on history. So you see which persons have solved certain types of tickets in past years. And by that, you can classify the incoming tickets with very high precision. And that's, I think, one of the interesting use cases we should look into. Okay, doesn't work here, maybe. Good. Now I will log into the PoolParty system and show you quickly how that looks like in reality. So that's the dashboard. Here you have your knowledge graphs, your taxonomies, your ontologies. I pick one of those. Let's assume you're working in the field of clothing industry. So you will find here, for instance, brands. You will find clothing by type, clothing by country, and whatever. So this is a typical structure you would maintain in PoolParty with the taxonomy server. And so here you have a couple of other functionalities like corpus analysis or ontology management, linking of knowledge models and stuff. And that's the new classifier functionality. So here you get this structure. You get training boxes, which basically are a repository, providing a repository of documents to train your classifiers. So you can reuse them again and again. You don't have to upload again and again stuff into the system. You just prepare the training boxes once, and then you can use those for many different tasks. So for instance, if you want to classify styles, maybe clothing styles, by let's say classical ones like British clothing, Australian clothing, Japanese clothing, and so on, you could prepare descriptions of such clothing styles in those documents here. So that's the first step. And then you can come up with classifiers. So here in that dashboard, you get an overview of already trained classifiers. So you see here, we've got 4 different ones currently. 3 of them are based on deep learning. This one, for instance, is based on deep learning and terms only, no use of taxonomies at all. In contrast, you see this other one, again, deep learning plus concepts and shadow concepts from a pre-built vocabulary, as I've shown you before. And here, a little bit further right, you see, and that's the most important information, F1 score. So you can see already differences here. And as I've said before, even 1 or 2% already is quite a big number when you have to classify a lot of documents. This one, for instance, was based on support vector machines. Here you get the F1 score again. Let's take a look at one of those, maybe this one, because it's the best performing classifier. So what you get here is an overview, a dashboard again. So you see the algorithm used. You could retrain it with another algorithm. You see the vectorizer. You can also configure stuff if you're familiar with the method behind. You can pick here different types of cross-validation. Tenfold takes longest time, obviously, but is highly recommended to come up with a good statistical sound correct result. And further down, you see different classes which were recognized correctly and incorrectly and so on. General performance just indicates whether the training material does help at all. So if you've picked the right documents or not. And down here you see the different validation numbers. There's also a chart you can look at if you like. And here again, the features you picked, in that case, terms, concepts, shadow concepts, or anything like that. And you can retrain your document classifier if you like, but that would take a little bit too long. Let's take a look also on the classifier documents themselves. So I could look at one of those, like the Argyll jacket. And what you see here are the extracted terms, concepts, and shadow concepts, and also their significance for the classification of the document. And by that, you could also figure out after a while if something was probably wrongly trained. And this is something we call, or DARPA actually called initially explainable AI, and we're following their patterns and also believe that explainable AI is very important. You can, for instance, use that one and say, I duplicate that and probably train it differently, maybe with naive Bayes. And I could now start to recalculate that, train that based on naive Bayes, and train the whole thing with another algorithm. That will take a while. So in the meantime, I will come to a conclusion. One question at the end. Will artificial intelligence make subject matter expert obsolete? And my provocative question maybe is, imagine you want to build an application that helps to identify patients and treatments pairings. Which will you prefer? Applications solely based on machine learning, those ones which are based on doctors' knowledge only, or a combination of both. And yeah, I leave it up to you. But maybe you will stay with me for a quick discussion. I will then open up the microphones. A short note on options, how you can try out Classifier. So first of all, there's videos on our website, one with a human voice and another with a robot voice. Again, you can pick one of those, whatever you prefer. So you will find it on our Semantic Classifier website on PoolParty.biz. And if you're interested in do some experiments with your own data, please reach out to us and contact us, and we will try to figure out the best configuration for you to be successful with that. So many thanks for your interest. I hope you had something interesting you found. Yeah, I hope some of you at least will stay with me for another minute or so. And we can also go through the questions. There were a couple of questions. I will also follow up on the questions now in this section, which is not part of the official, let's say, webinar anymore. So I now would like to, by the way, in the meantime, the classifier has finally come to a conclusion. So what do we get here? F1 scores 88%. So you see naive Bayes does not work that well, at least not in that setting as SVM or deep learning. But as I've said, there's several iterations usually necessary. Okay, so thanks again for staying with me. I hope you enjoyed, and yeah, hope to talk to you soon, and thank you and goodbye.